Okay, wait, I lied. I'm back. I realized that I wanted to show you one more thing because it could be relevant, right? You might have been wondering at the end of this last video, wait a minute, what do I do if in fact the interaction between two variables was significant? How do I interpret it then? Well, of course you have a graph to support your interpretation, but you also need more statistics to help support your interpretation. And so that's what I want to show you next. So let's pretend for a moment that this was a significant interaction between norm condition and political ideology in our understanding of how these variables relate to interest in reducing meat consumption. We would need to go forward and interpret that somehow. We would be able to say, hey, it looks like, based on this graph, that these two variables are associated with interest in reducing meat consumption. Sorry, not these two variables. Political ideology is associated with interest in reducing meat consumption differentially in the dynamic and static conditions in the following ways. But of course, we need some statistics to support that too. That visual description is not quite enough. So how do we follow up on significant interaction if we find one? And remember, we did not find one. We did not find one. I'm only illustrating. See, I'm making it official. Okay, great. So how do we do that? All right, well, there are two ways we could follow up to try to understand or appreciate how to interpret an interaction. And it really depends on what your emphasis is. So one way to follow up would be to look at the association between the x and y variables within each level of the other IV, which is norm condition. Okay, so x here is political ideology, y is interest in reducing meat consumption, and the other IV here is norm condition. So that's one way we could do that. And for this, I'm going to create an object that's called trends, because we're going to be using a function called emTrends, using out of the emMeans package. And we're going to tell emTrends, this function, to think about the example model that we created, and specifically to look at the association, oopsie, I meant to say equals here, not minus, the association between variable equals ideology and interest in reducing meat consumption, which it knows because that's how we specified things in this example model, separately for the different levels of this dynamic variable, which had values of 0 and 1, 0 for static and 1 for dynamic. And when we run that command, we have a new object here in the environment called example_trends. And we can see what that example_trends object contains by simply running that command and saying, hey, show me example trends. And what you can see here is that we now have the association between political ideology and interest in reducing meat consumption separately for people in the static condition, those people who had a value of 0 for the predictor that we created called dynamic, and for people in the dynamic condition who had a value of 1 for that variable. For people in the static condition, they had an association between ideology and interest in reducing meat consumption that was minus 0.345. And for people in the dynamic condition, it was minus 0.308. Those numbers will seem really familiar, I should say, because we went through exactly how you compute those on the basis of the intercept and the other estimates in the model. We can also see lower and upper confidence intervals for both of those variables. We can see that there is no 0 in between those values, so both of these estimates are what we would call statistically significant. And of course, we also know that these two estimates are in fact not significantly different from one another, right? Because, well, they're just not. the difference is not statistically significant. We knew that from the regression that we ran earlier. All right, so that's one way to follow up on this significantly not significant interaction. But if we had had a significant interaction, that would be one way to do it, is look at the association between your x variable and the y variable separately for each level of the other independent variable. Or we could actually see whether the difference between the dynamic and the static condition varies as a function of level of political ideology. And for that, we're going to use a function called sim slopes. So I'm going to call this object that we're creating example underscore sim slopes. Oh, and I meant to be typing this in the script, not in the console. Another way, difference between norm conditions at different, well, actually we'll say at lower and higher levels of the x variable, which is ideology for us. Okay, and yeah, we're going to create an object called example underscore sim slopes, and we're going to use the sim slopes function, which comes out of the interactions package. Again, we're focusing on the model that we created called example. Our predictor of interest here is called dynamic. That is the dynamic predictor. It's 0 for static and 1 for dynamic. We have what we're going to call mod x, or a moderator variable here, which is ideology. That's our the variable we had plotted on the x-axis. And we're going to tell it, we need to tell it, because political ideology is a continuous variable, it's not categorical. We need to tell it, well, how are we going to show differences between the two different conditions? At what values of the x variable? And what we're going to do is use a built-in function called mean plus minus, which means let's look at the impact of norm condition at one standard deviation below the mean for political ideology, at the mean for political ideology, and one standard deviation above the mean for political ideology. Okay? And when I run this, you'll see that I end up with something called example sim slopes here in the environment. And if I want to summarize it, I can just select that value, the name of that object, and I'm going to make this window a little bit bigger so we can see everything in the console. Here we have the simple slopes analysis. So what it's doing is saying, okay, at minus 1 standard deviation below the mean for political ideology, in other words, a value of minus 2.603, is the effective norm condition statistically significant? Here you see the difference between norm conditions, so it's dynamic less than static at a difference of minus 0.157, and a p-value here of 0.553, which means that that difference between the dynamic and the static conditions is not statistically significant. And a value of minus 2.603 is somewhere in here, and you can see, looking at this plot, that the static condition is above the dynamic condition at around that point in this graph, but that difference is not statistically significant. That's what this value of 0.553 here for the p-value means, that although there's a numeric difference there, it's not big enough for us to assume that it doesn't come from the null hypothesis distribution of t-values. Okay? We can do the same thing at 3 other points along these pairs, or this pair of lines here, right? At a value of the mean for ideology, so a value of minus 0.811, which would put us maybe around here in this plot, we can see that the mean difference there between the static and the dynamic conditions is minus 0.09, with dynamic being lower than static. And that's true here in the graph, right? So still that little orange line is a little bit above the green line, but the difference is too small to be statistically significant. The p-value is 0.631, which means that the difference between the dynamic and the static conditions here, even though numerically there is a small difference, is not big enough for us to conclude that it probably doesn't come from a null hypothesis distribution. So we can't reject the null hypothesis. And then same thing here, but now we're going to look at one standard deviation above the mean for political ideology, so at a value almost near 1, okay? And if I go to that point in this graph here, you can see that actually those lines are pretty close to overlapping. There is a very small difference here of minus 0.02. That difference is clearly not statistically significant based on this p-value. And so we really can't conclude that there's a norm condition effect there either, okay? So the point of this is that in this case what we're doing is we're looking at the effective norm condition at different points along the values for political ideology. If that had been a significant interaction, then what we might have found is that the value was that the norm condition effect was maybe significant for people on the liberal side of this scale, but not for people on the conservative side of the scale. But again, remember, the interaction was not statistically significant. So what we're doing here is an exercise just showing you how you would go about interpreting a significant interaction had we found one. But of course we didn't find one. And so there you have it. But now you know how to follow up on a significant interaction in a regression if you had the interest and the statistics to back up the need for it. So there you go. All right, bye for real now.